Okay, here we go, part 2. Let's go on to the next tools, Invert and ROI. The Invert tool changes the black shades to white and the white shades to black. Many users people prefer to display the chest region as they find it easier to see the large lung areas of the image with the grayscale inverted. So some radiologists just prefer to invert the black and white on the image, and it makes it easier to see, particularly in the lungs. ROI stands for region of interest. The ROI tools usually have several preset shapes such as circle, square, oval, and a freehand drawing tool. The user will select one of these shape tools, click on the image where the user wants to place it, and then resize or drag its borders over a structure on the image. Once placed on the image, it will give the user information about the density of the structure within the ROI. It might also give a reading of the size of the structure in the ROI. If a user sees a suspected kidney stone, the ROI tool can tell the user whether the stone is calcium or cholesterol by the density reading and the approximate size of the stone by measurement. So there's two types of kidney stones. One is made of calcium and one is made of cholesterol, and you can use the ROI tool to determine which type of kidney stone the patient has. Image link. The image link tool is used to link different series so they will scroll together. Image linking can be done automatically by the system, but at times the user will want to turn it off or manually link series. In a CT study, there may be several series in the coronal and sagittal plane. It may be advantageous to the user to have these linked and scroll together. This includes the series in both the current study and the comparison study. If different series were done, the automatic linking may not work, in which case the user may need to manually link the series. Conversely, if the images are of different slice thickness and automatically linked, the user may want to turn off the linking between the series. In summary, the user needs a tool to control how the series are linked together. Most PAC systems use some sort of a chain link looking icon to designate the linking tool. So imagine if you have two brain CTs side by side, and if the axial series has one series name in the current study and it has a different one in the comparison, they're not going to link, and you want to scroll the axials together. You need to manually link them together. That's what I'm talking about in the series descriptions there. Measurement and angle. The measurement tool allows the user to place a mark on the image and then draw a line to another point on the image, and the computer will calculate the distance between the 2 points. This is best used to measure linear objects that do not fit well into an ROI. The angle tool allows the user to measure the angle of 2 adjacent structures. This is commonly used on long bones to measure fracture angles. When you see a report that states fracture with displacement greater than 15 degrees, you know the angle tool was used to calculate that degree of displacement. So measurement, you draw a line, it tells you how many centimeters or millimeters that line is. Angle, it measures the angle to see how far apart 2 bones are when they're fractured. Annotate and Arrow. The Annotate tool is used to place a text box on the image where the user can make a comment about the image or a structure within the image. It's important that the text box does not cover up any other anatomy. Text boxes are usually placed around the edge of the image with an arrow to the part of the image the text box is referencing. You don't want to cover up any part of the anatomy with a text box. That is bad. Arrows are used for 2 purposes. As stated above, they can connect a text box to a part of the image, and more commonly they are used to draw attention to a key part of the image. The arrow usually means, hey, check this out. You know, it's like me pointing at something on a screen. Density. A density tool is used to give a reading of the density of a particular structure that isn't easily placed in an ROI or doesn't need a full ROI to be evaluated. It's very common when interpreting a brain CT or MR for the radiologist to use the density tool to determine whether something is a tumor or a bleed in the brain from other structures by taking density readings. Density on CTs and MR is expressed in Hounsfield units, designated by HU. On the Hounsfield scale, -1,000 is air, 0 is water, +1,000 is bone, +20 to +30 is white matter, +37 to +445 is gray matter. So if you can imagine, you turn on your density tool and you click on a particular part of the image, wherever you want to see, and it will give you density reading for that point that you've clicked on. And you can tell whether that's blood, water, bone, air by clicking on it and getting the density reading. Magnify. The magnification tool permits the user to place a virtual magnifying glass over a part of the image. Usually it is the shape of a circle or a rectangle. It can be moved around the image to magnify parts of the image. Many users find this easier on the eyes than zooming and panning. There's typically a secondary keystroke or pull-down menu that will allow the user to alter the size of the oval or rectangle so the user can magnify up to 1/4 of the image at a time if desired. 3-plane localization. This tool allows the user to determine an exact point in all 3 planes on cross-sectional imaging. By going to the Scout image and selecting the 3-plane localization tool and then clicking on a specific structure on the Scout image, the other series in all 3 planes will immediately move to that exact spot. This is much quicker than trying to scroll each series to the exact point of interest. The user would also have to disable the linking between series to get to a particular spot in all 3 planes. So having the system move all series to a particular spot in unison is a very handy feature. So I want you to visualize a 4-up image. And in the upper left corner you've got the Scout. In the upper right you've got the axial. In the lower left you've got the coronal. And in the lower right you've got the sagittal. If you just click on one spot on the Scout, the other 3 image series, axial, coronal, and sagittal, will all move to that particular point. So rather than try to scroll each one to that exact point, you just click on the one image and all 3 move to that spot. It's a quick way to, if you're looking at a tumor or nodule, something like that, to evaluate it quickly in all 3 planes, which is why it's called 3-plane localization. It would be impossible to list every tool for every PACS vendor. The ones discussed in this PowerPoint are common to all PACS systems. Each PACS vendor has its own interface and presentation format, or GUI, for the tools. Once you learn how the common tools work, you just need to learn where to find them in each PACS system you work with. Some tools are modality specific, such as 3-plane localize, which is really only used in CT and MRI. Mastering the tool set in your PACS system is critical for your success as a PACS admin. You will be absolutely loved by your radiologist if you have an expert understanding of the tool set and you can show them how to apply the tool set quickly and correctly to help them with their job. We'll try to get you some time in the lab to poke around with the tools in our PACS system. Thank you for watching.